Hey everybody, today we're going to be seeing what happens when you try to glue one of the world's slipperiest substances with one of the world's stickiest substances. Which one will win, sticky or slippery? I have here a tropical pitcher plant. And what's interesting about these plants is how they work. They're carnivorous plants in which an insect climbs around the surface of it, and once they get on the surface, they fall inside of it, and when they go inside of it, they just get digested in the digestive juices inside this pitcher or this little pot here. Now there's actually two surfaces of this pitcher that are slippery. One is the outer surface that causes the insect to fall in, and then the other is once you're inside of it, the net going up, that is also slippery, but they're slippery for different reasons. Now what's amazing about these is how slippery they actually are. No matter what the type of insect, once they get on that inner surface there, they just slip inside. Now let's see how slippery this actually is and what makes it so slippery. So let's see how slippery this actually is. Let's put an ant on the side here. Falls right off. Look at it just tumble down. So how is it that these pitcher plants are so slippery? How can an ant not even stick to it when it can easily climb a glass surface like this? Well, let's look at this under the microscope and see what it looks like. So what we're seeing here is tiny little wax crystals. And initially it was believed that these wax crystals detach when an insect adheres to it, and so it causes them to fall off. So what they did is they actually checked the feet of insects that climbed on these surfaces, and they found those tiny little wax crystals were adhered to their feet. So basically they thought originally that these were detaching from it, so kind of like it's climbing on a powder and it can't stay stuck to the powder, and so it falls off. But recent research papers have shown that it's not actually that these wax crystals are detaching, but it's actually due to the microscopic surface of the wax crystals. So these wax crystals have just the right surface roughness, that they're too rough for adhesion, but not rough enough for claws to attach to it. Okay, now we're gonna go ahead and see which one wins out of this. So I'm just gonna try to glue it together with the super glue. There's a drop on it. Just gonna touch them together. Gonna paste them together like that and come back and check in a little bit. Let's see if we can actually pull it apart when it's done. Okay, on this one we're gonna try something a little bit different. We're gonna see if I can actually glue something to it as opposed to gluing it to itself. We got the super glue on the wood here. And I'm gonna stick it to the plant. See if it actually glues. Okay, let's let this one sit and see what happens later. Okay, first let's do a control on the portion of the pitcher plant that's not sticky. Try to stick this stick to it. Okay, it's been about 30 minutes. It should be dry by now. Let's check if it actually stuck together. Here we go. Looks like it might have stuck. It did stick together in one part of it. In this part, it dried completely and it didn't stick. Okay, now let's check on our stick that was glued to it. Let's see, 3, 2, 1. Okay, it's enough to pick it up, but let's see if I can pull it off without ripping the leaf. It came right off. Look, you can actually see the glue on it. Completely dry and didn't stick to it. So in this case, the slippery one. Okay, let's go ahead and test our control. It just peeled right off as well. So you can see actually on here that there's tiny little hairs on there. So the hairs were actually stuck really well to the super glue, but it didn't adhere to anything under that because the hairs blocked it. So what's interesting about this is actually what was going on with the main slippery portion as well. except these were just tinier little wax crystals that flaked off so the super glue couldn't stick to it. And then this part was larger hairs, except this part of the plant wouldn't have been slippery to insects. So it's interesting how we define something slippery. In some cases, slippery could mean that you can't adhere glue to it, but an insect could climb on it easily. So it's interesting, in both of these cases, on the back of the leaf, which isn't even slippery to an insect, we weren't able to stick super glue to that as well. And the reason is because super glue is so sticky, it's a strong adhesive, that it basically forms this coating around anything that can flake off of the leaf, and it will just adhere to that, and then the leaf will break off of that surface. So the super glue is actually adhering really well to it, but the pitcher plant here just can't hold itself together. It just breaks apart and peels apart and delaminates. So I'm gonna call super glue the winner in this case, but only because super glue works by chemical bonds, and these pitcher plants aren't meant to stop a chemical reaction from happening, but they're meant to stop insects from adhering to the sides of it so that they stay inside of the plant. Now we know why the next surface was slippery due to the wax crystals, but the reason the top surface is slippery is due to a different reason. It's due to its microscopic structure that can keep the entire surface wetted. Basically, that top ring of the plant is completely wettable by rain or nectar, and it doesn't allow the pads of the insect to actually contact a surface there. And the way that it's able to keep that liquid spread around the whole surface is due to its microstructure. So what scientists did is they were able to mimic this structure that was able to immobilize a lubricating film on top of it, and they were able to mimic it with a non-biological structure. And they called this material SLIPS, and that stands for Slippery Liquid Infused Porous Surface. Now the SLIPS material was created by Harvard, and it can never get dirty, wet, or oily. It's something called omniphobic, meaning it repels oil and it repels water. So what's really neat about this is basically you can coat anything you want with it, and it can't ever have a material applied to it. Anything that's oil-based or water-based won't stick to it. So let's say you wanted a ketchup bottle that lets the ketchup come right out of it. You could make the ketchup bottle be coated with this SLIPS material and it would just slide right out. Or let's say you wanted a wall that's immune to spray paint. If you try to spray paint on it, it'll just flake right off. So the limits are endless when you have something as slippery as SLIPS. And it was all inspired by a pitcher plant. Hey everyone, thanks for watching another episode of the Action Lab. I hope you enjoyed it. If you did, don't forget to subscribe and also hit the bell so you can be notified when I release my latest videos. And if you have any comments or questions, let me know in the comments section and I'll try to get to them. And check out theactionlab.com so you can see the Action Lab experiment boxes. And thanks for watching, and I'll see you next time.